everyone. We're going to go ahead and get started. Thank you for coming today. My name is Dave Stanke, and I'm a developer advocate here at Google Cloud. And we're here today to talk about build and test. When we say build, we really mean build and test. Because if we didn't test our code, or if we didn't have tests, we can't say really with confidence that we built it correctly. So when we talk about this today, and in general, we use the word build as a shortcut for build and test. And sometimes we use the word test as a shortcut because it includes the build process. And I'm going to use that shortcut today as we go through this. Importantly, I want you to know that everything that we talk about here applies equally to building and testing. So what is this build and test thing? Well, that's the process where we take our source code, we run it through a series of steps. Might do some static analyses or linting, then we're going to do transpilation or compilation, packaging, and turn it into something that people can run and use as software. And the process by doing that is called a build process. And if you write software, or if people in your organization write software, chances are you have a build process. And chances are you use a build system to perform that build process. And this can vary depending on the language that you're working in. You probably are using it every day, or people in your organization are, but you may not think about it very much. But you're probably using it. So do we have any Java developers in the house? All right, you may be using something like Maven or Gradle. Any C++ developers? Few, all right. Common is make, maybe in conjunction with CMake. Any JavaScript developers? All right, familiar with Webpack or Gulp? These are all different build systems, and there's many, many more. So the headline for today is that you have a choice of build systems, and the choice you make can actually have an important impact on the success of your build. You might be able to get faster builds and tests, possibly much faster. Bazel is Google's build and test system, open source, available for free, and it's designed from the ground up to be fast. We can use GCP as an up level for Bazel to get even faster build and test reliably and consistently. All right, let's dig in a little on this build and test thing. Why do we build and test? Well, build isn't a requirement. Our software won't work until we turn it into something that can run. Test is a choice, but it's a choice that we're all making, right? Well, let's talk about that. There is a wide body of research talking about how testing is really good. Testing makes your code better, which makes your users happy, which makes your organization happy, which makes us successful as individuals. And when we add automation, we can do testing at scale. We can grow our code base, grow our organization, and keep our software running successfully, correctly. So look at the slide. It's all green. There's, oops, meant to get the laser here, the green laser. It's all green. There's no red. There's no pro-con. We're all doing it, right? We've totally bought into testing, and this is like in our bones at this point, right? Or is it? We did a study at Google across hundreds of organizations, and what we found is that test practices are falling far short of what our ambitions are. Very few organizations build every time they make a code change. And even fewer have comprehensive test coverage, by which we mean we have tests that cover every code path in our application. It's really common for a team to only run their complete test suite once a day, maybe less. And that complete test suite is not all that complete. So why aren't we testing? Do we really like getting woken up at 3 a.m. in the morning? No, I don't think that's it. We know the benefits, and we have the best of intentions. And then reality hits. The more tests we add, the more we realize that it takes time and resources to run these tests. And it becomes a drag on developer productivity. It's very common to kick off a build and then head out to lunch, right? And then you come back and, okay, build's not done. Let's go get some coffee. All right, came back. All right. Still going, I'm at 67%. All right, I guess it's beer o'clock. All right, here we go. Eventually, though, you want to actually get back to writing code. So what do? We take shortcuts. We turn down our test coverage. We run them less often. And then that leads to bit rot, Or don't even write the tests. Why write them if you're not going to run them? And this is why we're not testing at the level that we feel we should be. We end up in this conundrum here. As you step up your test practices, your code gets better and better, but your tests take longer to run, and you need more and more hardware. And that's a tough choice. You know, what's the sweet spot in here? We can test more and more and take longer to get our code out to production, or we can test less and get it out there sooner. We can ship it now, or we can ship it right. I don't know how to make that choice, and other people struggle with it too. In our study, we found that the #1 concern among teams with sophisticated test practice is balancing test frequency with the resources required to run those tests. So what if we could flatten that curve, get to a place where we can have more and more tests and run them more and more frequently without increasing an overhead that spirals out of control? Well, hello, Bazel. Bazel is Google's build system. It's been used by nearly every one of Google's thousands of engineers, tens of thousands of engineers, for over 10 years, and is available as free open source software. At Google, we have an intense commitment to testing. We exercise and validate every code path on every code change, and most teams maintain a very high level of code coverage. As we grew, we ended up running, as all of us do, into this problem, the conundrum of more testing meant more time. We didn't want to slow down and ship software less often. We didn't want to ship more bugs. So we created Bazel, we created Bazel to allow us to test all the things without losing that velocity. To do so, Bazel is designed with 2 major optimizations that allows us to run our build and test more efficiently. So the first is, don't repeat yourself. If you've already run something and it hasn't changed, why run it again? By reusing the prior results, it means that we can scale our build and test. As our builds and tests scale exponentially, our time doesn't have to scale that way because we're only going to retest and re-exercise the parts that have changed. The second major optimization is to build and work in parallel. So build actions, and especially tests, are generally very parallelizable. You might build one binary and run a whole bunch of independent tests on it. And so by having this fan-out ability, we can run across modern multi-core systems and get maximal efficiency. What can you build with Bazel? Well, just about everything. Bazel provides an extensibility mechanism where you use a simple Python-like language to write plugins. We call them build rules for various language. This is just a partial list of the set of languages that have been built by our community to extend Bazel. Now, I've shown this slide many times, and I was at a conference recently showing it off, and someone came up to me and said, all right, you got a lot of stuff in there, but what about OCaml? And I said, I don't know. I went to my phone and Googled it and found it. Oh, right, OCaml. We have that. So there's OCaml. We actually play a game at conferences sometimes called, Stump the Bazel. See if you can come up with a language that we don't have build support for. And if you do, it's pretty easy to write. So you can use Bazel across your entire organization for every language that you're working in today and tomorrow. Let's take a look at how Bazel works. So first, consider a traditional approach. We're going to try and build this code base. This is a portion of the TensorFlow code base. It's actually much, much more than that. And our goal is to get to an executable, something that we can run. So the traditional build process works something like this. First, we take all the things, and then we do this thing and that thing and the other thing, and then we cross our fingers, and hopefully we get something out that can run. Now, there's 2 problems with what I just described. One is all the things. Maybe we don't need all those things for this particular thing that we're creating. And 2 is, I said this and then that and then the other. This sounds very serial. And I think we know that modern software is all about parallel. So with Bazel, we took a different approach. The first thing we noticed is that source code is not a bunch of random stuff. Okay, mine sometimes is, but eventually I figure it out. And what I do is I write source code that is an interrelated set of highly structured symbols. So with Bazel, using a declarative configuration language, we define the units of code and how they interoperate. Bazel interprets that to create actions. And each action has fully specified inputs and outputs. These add up to a unique signature for that action. Each of these fully specified actions is independent and can be individually addressed. We know everything that goes into it and everything that we expect to come out of it. We composite these into a graph where the output of one action can become an input into the next. And these actions can be cached. If the inputs to an action don't change, then we don't need to regenerate the output. All right, let's zoom out. This is a graph of Bazel's build graph, a directed acyclic graph of all of the steps and the flow to get from your inputs to your output. This represents a very small one. So let's say we're going to make a change. We'll make a change to this file and that file. Well, everything upstream of that is going to need to be rebuilt. So we'll invalidate the cache for all of these bits. There's a fair amount to do here, but notice there's a whole lot that we don't have to do. And because of Bazel's build graph, we know for sure that we don't have to do it, and we're going to get the right output. Another thing we can see is that this area of the graph and this area have no common edges. And that means we can execute them in parallel. Now we're ready to build, we rock the graph, and arrive at our output. So putting it all together, when I say, Bazel, let's build and test this, Bazel's going to pull in the inputs, generate that build graph, then consult the cache to see if there's anything we can reuse. Prune out everything that's already been built. Then distribute that work across all the cores on my machine for parallel execution and rapid delivery. All right, let's take a look. Let's see, unlock my laptop here. So we're going to build an application. So it's a modest Java application for image recognition using the TensorFlow library. So it bundles TensorFlow's C++ native library to do the work. And there we are. All right, so we can see it on the right here. I'm running this using Bazel as an invocation runner. It just makes it a little bit more convenient. And we say, hello, welcome to the image labeler. What should we take a look at? All right, let's try image number 1. It looks like that. Who knows what that is? Say it out loud. Sunglasses. All right, do you think TensorFlow agrees? And yes, reasonable confidence. Let's try another one. All right. What's that? Can we guess? We're actually at a little bit of a disadvantage of here because of the ASCII art. I'll show you the real thing. What's that? Oh yeah, that's a strawberry. And TensorFlow thinks strawberry, 99.98% confidence. All right, it's working. I'm just going to make a change to this application. So I'm going to go into the Java code here. I'm going to do vim source main Java, and then myself, and then there's a greeter class in here. Oh, look what I've done. All right, we got a greeter class in here that says hello to you, the person running the program. All right, so let's change it to hello nexties. And oops, we'll go ahead and commit that. Why is my escape key not working? There we go. Oh my gosh. Vim. All right, did that work? Yes, okay. All right, and then we're going to go ahead and rerun our tests in Maven. You can see that Maven is going to kick up my test suite and go ahead and run through it. Then we'll rerun in Bazel. Bazel, test, all. So Bazel's going to analyze all my files, compile them, and run in parallel. Forgot to mention what I'm running this thing on. This is 2 GCE VMs, 16-core machines, identical machines. We're running Maven on the left and Bazel on the right. Bazel ran in parallel, and as you can see, very rapidly found that I have an error. Oh, my error is in my test. So we'll go ahead. Actually, I'm going to wait for Maven to finish. Maven's running through all of its tests, taking a little longer because it's not parallelizing, still doing all the work. And should be just about done here. There it is. And they found the same failure. All right, so the failure is in my test class. Let's go ahead and edit vim source test Java, blah, blah, blah. And I have a greeter test. And this funny stuff again. Go ahead and edit anyway. All right, and what did we say? We said hello nexties. That's like catching on, right? We're calling ourselves that? Nexties. All right, and we'll save that. And now we have it on this one. So what we do, we say just continue, right? All right, and then we're going to rerun our build and test action. Maven on the left, Bazel on the right. So Maven's kicking off and run. Oh, I failed somehow. But as we can see, Bazel did it much faster. It's capital, all right. See, this is a coding test. Thank you. Success. And go ahead and capital that. Rerun. It's only going to rerun that one test that changed. And we passed in a very short amount of time. So, whoops, what button was that? All right, so to recap, with Bazel, we made a change. Bazel's going to look at its cache and not bother rebuilding anything it doesn't need to. Then it's going to fan out and use all the cores on my machine to build in parallel. Now, I was running this demo on 16-core machines. Do you use a 16-core machine every day? Maybe you do. I don't. I use this little laptop with 2 cores. And sure, you can give all of your developers 16-core machines. And most of the time, they're going to be real happy. Running an IDE doesn't take a whole lot of horsepower. And if we're doing a modest build process, it's still pretty good. It's a little wasteful, but everything is working fine. But eventually, these machines are going to start to look underpowered. This is because build is intrinsically a spiky workload, which means our developer machines go from being overpowered to underpowered. And yes, even with Bazel, because Bazel can exercise all of the cores on one machine, but it can't conjure up new cores out of thin air. Or can it? Remember, each of these Bazel actions is an independent unit of execution, which is how we can cache so aggressively and shard across all the cores of a machine. So how about we tap into the cloud and get a bunch more cores? We can scale way beyond a single machine. And everyone in the team can share that pool of worker cores. So we can bin pack those spiky workloads. When I need a build, I'm going to grab a bunch of cores. And when I'm done, you can grab a bunch of cores. And we can scale the total pool to whatever we need for our team. Also, we can move our cache up into the cloud. So if anyone on my team has previously built something, then everyone gets to reuse that work. This is great for getting new team members onboarded. A first build for a new team member isn't starting from scratch. It's starting from whatever the build was that the experienced person made yesterday or this morning. Today, I am excited to introduce Remote Build Execution for Bazel. It's a Google Cloud Platform service which has just been launched to alpha. It's inspired by the services that we use internally at Google, which are a big part of supporting our engineering culture and commitment to tests. It's based on open source APIs developed by the Bazel community. This is a fully managed Google Cloud service, provides scalable worker pools for massively parallel build and test workloads, and a shared cache that every build client, whether a developer or CI, can leverage. Let's see it in action. So we're going to build that same application that we looked at earlier. But this time, we're going to go into the TensorFlow source code. TensorFlow is a huge project, massive C++ source code, tens of thousands of files and tests. Let's make a change. So Vim. If we go into the core here, lib, there's some string libraries, and here's a file within there. And we're going to modify this global identifier. Let's see. Oop. So what should we have our global identifier be? Let's go with Hello, oh, all caps, didn't mean that. Hello, nexties. I feel like I heard someone saying that. It's like what people are calling the attendees. And go ahead and quit out of that. All right, and then on the left side, we'll go ahead and rebuild with Bazel. And of course, it's going to run through all of its inputs and figure out what work it needs to be done and distribute that across all 16 cores. Okay, there's 7,000 or so different bits that it needs to run. It's actually going to find a few more as it runs. On the left, we'll run that same thing. Test, all, all. And this time, I'm going to use a configuration that includes remote build execution. Do that same analysis and start running, and oh my gosh, look, we are running on 600 cores. So this work is being distributed to 600 individual workers in the cloud. This is, again, using that open source protocol for remote build distribution. It's based on gRPC and protobuf, and it uses Docker containers to provide an isolation mechanism. The container is where your work gets executed, and that's part of the input to the build that's happening. And it's executed in our fully managed service that carries the same commitment to performance, reliability, and security that you've come to expect from GCP. So now, another benefit of working in the cloud is that we can send our outputs to a shared place. So I want to show you a cool additional feature, which is this UI for build results. This is representing the build I'm doing right now. You can see a list here of all of the work that Bazel has decided it needs to do and is currently running through, and a successful rate, and some of them that haven't happened yet. We've got our invocation log. Here's a full list of the invocation details. This is what Bazel is going to do. And we can get artifacts, the things that Bazel has built. We can go ahead and download our intermediate libraries and things straight out of the cloud. This is available to everyone on your team. So if I'm having a problem building, I can go to my overview page. I can take this link and copy that and send it to a colleague. And they can understand my build and the needs that I have without having to re-download and rebuild everything themselves. Or they can go ahead and rebuild based on knowledge of exactly what Bazel build I did from this input. All right, let's go ahead and refresh and see how we're doing on our build. Looks like we're getting pretty close here. We'll check back in. All right, now we come down to a bit of a pinch point. You can see that we're doing our linking. That tends to be a bottleneck. We're still distributing across dozens or hundreds of individual nodes, a lot more than I could process on one team. All right, and we've started running into the tests, and oops, I have a test failure. All right. Using this UI, that's going to pop right to the top. Here's my failing target. Click into my strings test, and what do we find? Oh, right. I was supposed to write hello nexties in my test, but instead, it still says TensorFlow 1.9. Again, this is a great way to collaborate with teammates. Send this to someone who understands this test suite, and they can help me understand it. I'm not a C++ expert, but in this case, it's fortunately pretty clear what I'm supposed to do about this. Let's pop back over. Still running off a few additional final last bits. Final testing. And there we go. We see a summary of all the things that passed and that one test that failed. I'm going to go ahead and make an edit there. Let's see, it's under lib, strings, numbers, test. All right, and this time we'll get the capitalization correct. So it was, here, you know what? How about we copy and paste? No fat fingering here. And go ahead and paste that in, save, and I'm going to rerun my test suite. This time, the only change I made was to that one test file. We're going to recompile the test. This is running again on the remote. We're going to relink that to single action, so it's running in single-threaded mode effectively. And rerun, and what you see is It cached all of those previous results and only reran the one test that I needed to run. Again, this works across your whole team. So if I'm the one who made the original error and my colleague made the change, they're going to inherit all of the test results that I got that passed. It's really great for making your people on your team effective, fast, happy. So to sum up, we used a shared cache to deduplicate across your entire team. The shared worker pool means I can parallelize to the scale of the cloud. And cloud-hosted UI improves our effectiveness as a team, communication, and joint debugging. Now, Cloud Build. This was announced this week. Hopefully you've been hearing about this. It's a fully managed CI/CD system on GCP, and it has out-of-the-box support for Bazel built in. There's a supported build step, which makes running Bazel workloads on Cloud Build really simple, just a couple lines of code. And it's got a Bazel-optimized results UI for collaborative troubleshooting. So you can have you can have Cloud Build driving your process as part of a CI system, getting that same shared cache and same shared giant cloud compute pool. Using RBE for your CI builds enables you to fully test every single change. From one commit to the next, typically these are all small incremental changes. And so then the same is true of pull requests and even developer builds. So running using the shared cache and the distributed pool means that every change can be tested because everyone's only going to reperform the amount of work that it needs to. So the time it takes to run your test suite is proportional to this amount of change made, not to the total size of the code base. With remote build execution, we've been partnering with several teams, Google projects and GCP customers, as part of an early access program for RBE. And these partners have seen great improvements in build speed and reliability. Some of the workloads our customers are running include Scala web services, C++ system libraries, and IDEs written in Java, where we're doing full headless testing of those interactive environments in the nodes on RBE. One of those customers is the TensorFlow team themselves. They build their very large polyglot project on RBE. And they've been piloting remote build execution with us and have achieved a 5x improvement in their build speed. That's coupled to a 5x reduction in the amount of machinery necessary to do these workloads. So 5x plus 5x, I don't know if that's a 10x or a 25x, but it's a lot of x's, and we're really excited about what we're being able to achieve here. They used to have a long backlog of pull request testing. They'd had this one poor engineer who had to very carefully mete out the tests against this fragile infrastructure. By using these services, they've been able to run on demand every pull request, a real linear flow, and their contributors are much happier. So summing it all up, Bazel makes your build faster by maximally reusing prior results and fanning out the remaining work across all of the cores on your machine. With GCP, we take it to the next level, globally reusing prior results and fanning out the work across the cores in the cloud. If you're ready to get started with Bazel, there you can find installers for Mac, Windows, and Linux on the Bazel website, as well as demos, tutorials, and great documentation. You'll also find references to the community. We've got a mailing list at Bazel Discuss, very active, Stack Overflow communities, and we have a conference coming up in New York this year. It's our second annual Bazel conference, BazelCon 2018 in October. Find information for that on conf.bazel.build. To get started with Bazel on GCP, shoot us an email at rbe-inquiries@google.com. Again, that's rbe-inquiries@google.com. We have found from our own testing, inquiries is actually kind of hard to spell. So take a picture of that and type it exactly. Maybe those new G Suite features you saw will help autocorrect it, I'm not sure. But please reach out to us. We'd love to learn about your builds, challenges you're having, and how we can help you have faster, more reliable builds. We also have a couple of the senior engineers from the team here in the room today. They and I will all be outside. We'd love to talk to you. Please come. That's them. Please come and tell us what you're up to and ask us questions.